Hi guys, so we're going to be starting our transformations unit. So before we get started with our first example of reflecting this quadrilateral, let's talk about some definitions. Okay. So first of all, a transformation, what it does is it maps an initial figure called a pre-image onto a final figure called an image. Right? And so below are some of the types of transformations that we're going to be learning. Right? So translation is a slide. Reflection is flipping it, okay? Rotation is turning your figure, and dilation is either making it bigger or smaller. Okay? So we're going to start off with reflections, and what a reflection is, it's a transformation that represents a flip of a figure, okay? And they can be reflected in a point, a line, or a plane. Okay? So here in this example, line M right here is a line of reflection because what it does is it takes figure ABDE and it flips it across that line here. Okay? In this bottom instance, point P is a reflection point, okay, because what it does is it reflects Y across that point here. It takes X, reflects it across that point here. And it takes U, reflects it across the point here, and Z reflects it across the point here. Okay. When we reflect a figure in a line or in a point, the image is congruent to the pre-image, and so a reflection is known as a congruence transformation or an isometry. Okay. So with that in mind, we're going to start off with my first example here. Okay. This, you'll notice, is a little bit different from the book. It's the same idea, but since the book doesn't quite explain really how to do it, I'm going to do that. Okay? So what you're going to need when you reflect a figure that isn't on a coordinate plane is you're going to need your compass. Okay? So I'm going to take my compass out. Okay? And we're going to reflect this quadrilateral across this line. Okay? So what I'm going to do is I'm going to start with point C, okay? And what you're going to do is you're going to put your pointy end on point C, and you're just going to cross the line of reflection twice. Okay, so here we go. Okay. Then it doesn't matter which how big your compass is next. You're going to now go to those points of intersection. And so I open my compass bigger, and you're going to make two other sets of arcs. Okay? And then now what I have here is I have this perpendicular line to my line of reflection. Right? So here you can see this forms a 90-degree angle. Right? Because what happens is our reflection is going to be perpendicular, right? The line in which it's reflected is going to be perpendicular to this. Okay? So then how do I find where C actually is? Okay? So I know C is somewhere along this line of reflection. Okay? So what I can do is I'm going to measure how far C is from my line and where I intersected. So this perpendicular part. And then I'm going to go that same distance and make a new arc. And so here, this point is now the new C prime. There you go. Okay. However, there is a faster way we can do it without having to draw this line and then measure it. Okay. So I'm going to show you the shortcut way, and I'm going to explain how it works. Okay. So I'm going to do that with point B here. Okay, so again, I'm going to open my compass to however big to intersect my line twice. Okay, you're going to be making a lot of arcs, so it's important to keep track of which arc is which arc. So you might even want to color code it, like these are all the ones for C, okay, and this one is the one for B. So I'm going to cross it here. Okay, instead of doing the whole arc, I'm just going to cross there so I don't have as much pencil mark. Okay? And then, leaving my compass the same, I'm now going to go to those 2 points of intersection that came from B. I'm going to make an arc, point of intersection from B, and I'm gonna make it up. Oh, perfect. Just got it. Okay? And so this is going to be my B prime. Okay? And so you might ask, well, how come that one worked? Okay? The reason why is because we learned about our perpendicular bisectors, right? That it's going to be equidistant. So the distance from here to here, this line of reflection, and here to here is the same distance from here to here and here to here. And so that allows me to save some time. Okay, so I'm going to do the rest for A and D, okay, a little bit faster now. Then we're going to connect all of our dots. And so A, open my compass so it crosses it twice. So once here, once here. Moving to that intersection, cross, cross. Okay, so here is my new A prime. And then doing the same thing for D, opening my compass, any length will do. Okay, crossing it twice, so here and here. Leaving my compass the same. I'm going to move to the intersections that were formed with D. Here and here. And so this is my new D prime. Okay, and then now all I have to do is connect it in the same order that it was connected in my image, in my pre-image. So C and D, D and A, B and A, and B and C. And here you can see that it is a reflection over this line. Okay, so because you can't do the CYP in your book unless you want to copy it. So what you're going to do is on a separate sheet of paper, draw any triangle in a line, and then you're going to, reflect your triangle across your line. Okay, so you should have gotten a reflection. Your triangle obviously might look different from mine. Your line might be placed differently from mine, right? One way you can check is if you fold on your line of reflection, your two figures should lay on top of each other. Okay, so if you got that right, you can move on to our next example. If not, here is your explanation. Okay, so basically it asked me to draw a triangle, so I did, and a line. Okay, and then to reflect it, all I did is I opened my compass to any length as long as it could cross my arc, my line twice, and then I drew my arc, and then to keeping my compass the same, I went to those marks. And then I made two other arcs. And wherever that intersected now, that was my new point. Okay, so I even color-coded it so that way it made it easier to keep track of which ones were for which. Okay, then I did the same thing for my next point, opened my compass to any distance, crossed my line of reflection twice, then, keeping my compass the same, moved to those intersections and crossed and made two more arcs. And wherever those two new arcs crossed, that was my new point. Okay? And then same thing for my last point here, opened my compass to any length as long as it crossed my line of reflection twice, mark, mark, then went to those intersections, leaving my compass the same. I did two more arcs. And then where those two new arcs intersected, that was my third point. And there you go. Okay, so this is how you do it when it's not on a coordinate plane. Our next example is going to look at it when it is on the coordinate plane. Okay, so here I have triangle KMN. I'm going to graph it and then I'm going to reflect it. So K is here at 2, -4. 1, 2, 3, 4. Okay. M is at -4, 2. 1, 2, 3, 4, and then up 2. Okay. And then N is at -3, -4, so 1, 2, 3, 1, 2, 3, 4. Okay. And then I'm going to connect them. And then since I'm just going to do it 3 times across different types of reflection, I'm just going to graph it really quickly for the other two as well. So this is K, this is M, and this is N. Okay, so for my first one, I want to reflect it across the x-axis. So just to help me, I'm going to highlight my line of reflection. So the x-axis, that is this here. Okay. Okay, so if I'm reflecting it, I'm flipping it over. So what I'm going to do is I'm just going to count how far it is from that line and go that same distance away. So from K to this line, this is 1, 2, 3, 4 away. So I'm going to go 1, 2, 3, 4 away. And this is my new K prime. Okay. I'm going to do the same thing for N. This is 1, 2, 3, 4 away. I'm going to go 1, 2, 3, 4 away. And this is my new N, so N prime. And then M here is 1, 2 away from the line of reflection. I'm going to go 1, 2 away. And here's my new M prime. Okay. Then I'm just going to connect it. And what you should see then is if I folded my graph on this pink line, you would see that it lies on top of each other. Okay? So what are my new coordinates? So K prime is now at 2, 4. Okay? M prime is now at -4, 2. And N prime is now at -3, +4. Okay? So how do these compare? What changed for K? Okay? What changed for M? Oh, sorry, -2. And what changed for N? Okay? And what you should see is that when I reflect, across the x-axis, my original x and y points, what changed is that x stayed the same, right? It's still +2, -4, -3. X stayed the same. However, my y values changed signs from -4 to +4, 2 to -2, and -4 to +4. So y changed sign. And so that's what happens when we reflect over the x-axis. So now, even if I don't graph it, I was given points and told it was reflected over the x-axis, I would know that it's this. Okay? Okay, moving on to B here. Graphed KMN, here it is. Okay? This time, we want to reflect across the origin. Okay? So that's here. Okay? Okay. So then let's start some of our points. Okay. So here, starting with K, okay, what I'm going to do is note how K gets to the origin. So from K to the origin, it's 4 units up and 2 units left. And if I repeat, 4 units up, 2 units left. If I repeat that pattern of 4 units up, 1, 2, 3, 4, 2 units left, this is my new K prime. Okay? And here, what you can note is that I reflected it across this line. Okay? Took it and I flipped it over. Okay. So I took it and reflected it over. Maybe don't need that. Okay, then I'm going to do the same thing for M. Okay, so if I note for M, this is 2 units down, 4 units right. So I'm going to go 2 units down again, 4 units right. Okay. This will be my M prime. And then note N, I went 1, 2, 3, 4 units up, 1, 2, 3 right. So I'm going to go 1, 2, 3, 4 units up, 1, 2, 3 right. This is N prime. Okay. And I'm going to connect. And these are my new points. Okay? So comparing the coordinates of the vertex with the coordinates of the image Okay, K prime is now at negative 2, 4. M prime is now at 1, 2, 3, 4, negative 2. And then N prime is now at 1, 2, 3, and up 4. Okay. And then so comparing the coordinates of each to that, right? So 2, negative 4 became negative 2, 4. 4, negative 4, 2 became 4, negative 2, and negative 3, negative 4 became 3, comma 4. So what I note is that when I reflect across the origin, how xy changes is that the numbers stay the same. However, what happens is that the sign changes, right? So the 2 becomes negative 2. The negative 4 becomes positive 4, right? The negative 3 becomes positive 3. And the same thing happens for the y. So x and y stay the same place, okay? But their signs both change. Okay? Okay, let's do the last one here before you try one on your own. So here, this time, I'm reflecting across the line y equals x. Okay? So that would be this line here. So the slope of this line is 1, right? And so in order for k prime to be perpendicular to it, its slope is negative 1. So from k to this line here, right, it's it's up 3 units, left 3 units, okay? So I have to do the same thing to get k prime. Up 3 units, 1, 2, 3, left 3 units. So here, right where m originally is my k prime. Right? So it's a little bit harder to see since I used this. Okay? So then I'm going to do the same thing. So n is going to move from negative 3, negative 4 to negative 4, negative 3. So n is going to be here because it's about half a distance away. So half. This is n prime. Okay? So then m here, okay, negative 4, 2, it's now going to move to 2, negative 4. Okay. So writing down my new points, k prime is at negative 4, 2. M prime here is at 2, negative 4. And n prime here is at negative 4, negative 3. And if we compare it to the originals, basically what happened is that x and y switched places. So when we reflect across y equals x, what happens is our original xy is now going to trade places. So your old y is now going to be your new x, and your old x is now going to be your new y. There we go. Okay. You can see the rules for each of these here on page 499 here, and how we can find those coordinates. And then one way you can always check is if you fold across that line of reflection, they should be on top of each other. Okay, so why don't you try CYP2A on your own, and then once you're done, come check your answer. Okay, this is what you should have gotten. R prime is at 2, 2. U prime is at negative 3, 1. D prime is at negative 4, negative 1. And B prime is at 2, negative 2. And when you compare the coordinates of the pre-image, the original, and the image, what you should notice is that the x's change signs. So negative 2 to 2, 3 to negative 3, 4 to negative 4, and negative 2 to 2, but the y's stay the same. There you go. Okay, so now let's move on to our next example. Okay. So here, Adil and Natalie are playing miniature golf. Okay. Adil says that reflections can help make a hole-in-one on most miniature golf holes. Okay. Describe how he should putt the ball, or hit the ball, to make a hole-in-one. Okay. And so here is the explanation. So, if Adil tries to putt the ball directly to the hole, he will strike the border as indicated by this blue line. Okay. So, he can mentally reflect the hole in the line that contains the right border. Okay, so here, and then he reflects it. Okay. If he puts the ball at the reflected image of the hole, right, so here, right, and he reflects it. So if he aims here for it, because this is the reflection of the hole, if he pretends to put it directly to this hole, the ball will strike the border and it will rebound on the path towards the hole. Okay. Right. So this is just explaining kind of how this reflection thing works. Okay. So why don't you try CYP3, and then once you're done, come check the answer. Okay, so what you should have gotten something similar to this. So Tony should aim his bounce pass at a point reflected underground, a distance equal to the height of Jamal's waist. So here's Jamal's waist, right, and it's reflected here. If he, like this, it will boom, this will reflect, and then it'll go up to here, and he'll be able to catch it. Okay, so there you go. Okay, so moving on to our last example. Okay. So here, we want to determine how many lines of symmetry a square has and determine whether a square has point symmetry. Okay? So let's look at the book to see what it means. So some figures can be folded so that the two halves match exactly. Okay? The fold is known as a line of reflection, called a line of symmetry. For some figures, a point can be found that is a common point of reflection for all the points on the figure. And this common point of reflection is known as a point of symmetry. Right? So here, for example, the letter F doesn't have any. There's no way to fold the letter F so that way both sides would match. Okay? For this triangle, there's one line of symmetry. We can fold it like this, and it would work. For this arrow weird looking cross thing, we can fold it here, and then top and bottom would match, or we can reflect it like this, and then they would match, right? This sun-looking thing, we have multiples, right, and that would work. Okay. For the F in the triangle, there is no point of symmetry. However, for this cross-looking thing and the sun-looking thing, there is a point of symmetry, and note that it's kind of where all of these points, these lines of reflection cross. Okay. So that takes us to our next example to determine how many lines of symmetry a square has. Okay? So one thing we can do with our square is we can fold it in half vertically. Okay, this isn't going to be perfect, but okay, well, very not perfect. Okay? We can also fold it horizontally. Maybe I should just draw it. Oh, it looked better. Still not perfect. Okay, we can fold it across like this. Okay, and we can fold it across like this. Not very good, but there you go. Okay, so here this has 1, 2, 3, 4 lines of symmetry. That's how many a square has. Okay, so where is the point symmetry? This one does have a point symmetry, and it's right here, or in this picture at point P, because the reason is AP and PA prime is the same, CP and PC prime is the same, and BP and PB prime is the same, and so on and so forth. Okay? So why don't you try CYP4, and then come check the answer when you're done. Okay, so what you should have gotten is you should have gotten that it has 2 lines of symmetry. okay, for your rectangle here and here. The diagonals don't work because if you did the diagonal and you folded it on top, it wouldn't be on top of each other. Because if you folded it right along here, this side would be on top of this, and this is longer than this. Okay. However, the rectangle does have point symmetry. Okay. And it's this point kind of in the middle or in the center there. Okay. So that's it for today. Have a great rest of the day. Bye, guys.